Hi, my name's Elaine Wolf. I'm a retired elementary and middle school math teacher. I design paper models which integrate art, architecture, engineering, and mathematics. I use a Silhouette Cameo to create scale drawings and to cut out my paper model parts. I post my free designs and how to assemble them on my blog, papercraftetc.blogspot.com. I'm a collaborator for the maketolearn.org website, which brings the art of making to learning. It was during one of these weekly meetings that Michael Littman, a professor at Princeton University, discussed the book On the Divine Proportions by Luca Pacioli. He told the story about how Luca Pacioli, an Italian mathematician, was aware that there is a harmonic order and proportion in nature. This harmony leads to the golden ratio or divine proportion. It is based on a line which is divided into two segments, and the ratios of the segments are calculated. The result produces the golden ratio value of 1.618. This value is also known as phi. Phi is a number which appears frequently in nature, and our eye is used to seeing this proportion. Leonardo Da Vinci was Pacioli's student during this time, and he illustrated the 59 polyhedron models in the book for his teacher. The illustrations are unique because this was the first time that skeletal models of the polyhedra were drawn. Here are two examples of the models that I created from the Da Vinci drawings: a solid elevated icosahedron and a hollow elevated icosahedron. Notice that the hollow model allows you to see the interior landscape of the model with all of the vertices and edges. Upon examining Da Vinci's illustrations, I knew that I had to recreate them in paper. I made all 59 models by designing nets of the polyhedron. Here is an example of a cube net. The net is folded and then glued into a cube. After seeing the interesting results of the models, I wanted to further my investigations. I found an English version of the book and discovered that Pacioli wrote about inscribing the polyhedra into one another. Since I had already designed all the polyhedra, I thought it would be an easy task to inscribe them as Pacioli and Da Vinci would have done if they had the Silhouette software and cutting technology. Pacioli wrote in his Divine Proportion book about these inscriptions. The 5 Platonic solids, the tetrahedron, cube, octahedron, dodecahedron, and icosahedron, can be derived from a single one, the dodecahedron, which, according to Pacioli, quote, sustains the existence of all the others and governs the manifold harmonies and interrelations among all 5, unquote. Since the dodecahedron is the basis for all others, Pacioli claimed that it would be only mathematically possible with a specific proportion, which he named the divine proportion. Pacioli wrote about the inscriptions of the 5 Platonic solids using the sphere method of calculating the side lengths of the interior polyhedron. I found out while making the models that as the inscribed polyhedron size approached a sphere, the size calculations became more complex and difficult to calculate. With some investigation on the internet, I discovered an article about maximizing the side lengths of the interior polyhedron. The computations for 6 of the polyhedra were just calculated in 2018 by the article's author, Moritz Fersching. These maximal size calculations were in the annals of unsolved geometric problems for many centuries. Using Fersching's calculations, I was able to complete the 20 inscribed Platonic solid models. Here are the Platonic solids that are inscribed in a tetrahedron. So these are the ones, these are all tetrahedrons with inscribed Platonic solids. And then after I did those, I did the cubes. And there's the cubes. Oops, this one moved over a little. That's what happens. Okay, there you go. And then after that, here's the octahedron. I don't know if you can see the octahedron. And then after the octahedron, I did the dodecahedron. There's the dodecahedron. And last but not least, here we go, the icosahedron. Thank you so much. I hope you enjoyed my talk about the inscribed Platonic solids, and I hope you visit my website, papercraftetc.blogspot.com. Thank you.